Question 4 on page 49 is a word problem, and it's saying that we want to mix 400 grams of an alloy that contains 60% silver with some amount of an alloy that contains 75% silver to produce 600 grams or more of an alloy that contains 420 grams or less of silver. And then we want to know what the maximum and minimum amounts of the 75% silver alloy that we can use. So I'm going to start by saying that X is the amount of the 75% silver alloy that we have. That we're going to use, and X is going to be in units of grams. So what we want to find out in this question are the max and minimum values of X that we can use. Okay, so I'm going to start by writing out an inequality from parts of this question that is an inequality for the representing the amount of silver we have in our alloy. So not the total amount, not the total grams of metal, but just the grams of silver. I'm going to say that's silver here. Okay, so if we have 400 grams of an alloy that's 60% silver, to find the amount of silver, that's going to be 400 times 0.6. So I'm just leaving out the grams in these expressions here to make them more simple, but all the units in these inequalities are going to be in grams. Okay, so that's going to be 60% of 400 grams, and that's going to be the grams of silver we have from that first alloy. So we're going to add that to the grams of silver from our second alloy. So we don't know the total amount of the alloy we're going to use, that's X. We're going to multiply whatever that is by 0.75 to get the amount of silver we're getting from that alloy. And so the amount of silver from each of these alloys added together, we want that to be less than or equal to 420 grams. So that's the inequality we get there. And I'm just going to evaluate this out and solve for X. So 400 times 0.6 gives us 240. This is just, I'm going to leave it 0.75x less than 420. So I'm going to subtract 240 from both sides. Cancels out, and I get 0.75x is less than or equal to 180. If I divide both sides by 0.75, this gives me x is less than or equal to 240. So that's what I get from this first inequality, but we can write another inequality based on the total grams of metal we get from adding our two alloys. So this is total metal. And so from our first alloy, the 60% one, we're taking 400 grams. And then from our second one, we're taking our unknown amount, X, and we want the addition of these two alloys to be greater than or equal to 600 grams, because the question asks us to produce 600 grams or more of the alloy. So if we solve this for X, I'm going to move the 400 over, cancels, and I get X is greater than or equal to 600 minus 400, which is 200. So from these two inequalities, if I combine them, what I get is that X has to be greater than or equal to 200 and less than or equal to 240 to satisfy what's given in the question. So if we remember, these units are in grams. So this is saying that X has to be greater than or equal to 200 grams and less than or equal to 240 grams. So if we want to find the max and min, this means that the maximum amount of the alloy we can use is 240 grams, and the minimum is 200 grams because we have less than and equal to or greater than and equal to here. So X can equal these values. So these are the max and min amounts of our 75% silver alloy.